आप में से कई लोगों ने मुझे कई बार कहा है कि भाई शिवा भाई, रोजेंडर भाई, जो भी आप लोग मुझे बुलाते हैं, कई बार आप लोगों ने कहा है कि हम एस्ट्रोनॉमी पढ़ना चाहते हैं, हम एस्ट्रोफिजिक्स पढ़ना चाहते हैं, हमारा इंटरेस्ट इस तरफ है, हमारा इंटरेस्ट एस्ट्रोनॉमी में है, हम एस्ट्रोफिजिक्स कॉस्मियोलॉजी इसके बारे में जानना चाहते हैं। मेरी जो वीडियोस हैं लाइफ साइकिल ऑफ स्टार और इंट्रोडक्शन टू एस्ट्रोनॉमी, उसमें भी आप लोगों ने कई सारे सवाल पूछ रखे हैं। तो कई बार उन सवालों के जवाब जो है मेरे पास होते नहीं है भाई, क्योंकि मैं उतना सक्षम नहीं हूं कि आपके सवालों के जवाब दे सकूं। पर एक चीज है, मैं इतना सक्षम जरूर हूं कि ऐसे लोगों को आप तक लेकर आऊं जो आपके इन सवालों का जवाब जो है वो जरूर दे पाए। तो आज जिन्हें मैं अपने शो पर लाया हूं, जो मेरे को सौभाग्य प्राप्त हुआ है जिन्हें अपने शो पर बुलाने का, वो इंडिया के एक जाने माने एस्ट्रोफिजिसिस्ट हैं। और अभी के टाइम पर मैं जितनी हिंदी बोल रहा हूँ सुन लो मेरे भाई, क्योंकि आगे चल के अभी थोड़ा अंग्रेजी में हम लोग बात करेंगे, थोड़ा इंग्लिश में बात करेंगे, बिकॉज of some language barrier, but that doesn't matter because the knowledge which you are getting from this podcast is the most precious, and the knowledge is the most important thing that you can get from this podcast. So just put on your captions and then you can just watch the interview, or you can hear it on Spotify or wherever you're listening to it. So let me just call Dr. Jayant Murty on the podcast. Sir, very welcome to you, and how are you?
Very well. It's always nice to be on these podcasts, and I'm sorry I don't speak Hindi well enough
That's
to
not
manage or understand.
that's
Actually,
not that's not a problem, sir, and you don't have to be sorry for this. Uh, we all have some language barriers, so we can we if we know these two language, English and Hindi, we can just have our communication. So that's not a problem
sure.
until we are not talking in Tamil or Telugu.
Telugu I can manage.
Yeah, but
Telugu
I
I can
cannot.
manage. Kannada I can manage. Yes, Telugu or Kannada I can manage.
But I know a little, even just one or two sentences in Tamil. Just that's it.
My Tamil is also quite poor. I can understand better than I can understand Hindi, but still not well.
Right, sir. Right. So, sir, let me start with the first question. That your research, that is about the interstellar dust, space research, and the other interesting thing that I would like to ask in the later part of the interview. Before that, let me just ask, sir, tell us about your research in the stellar dust and the space missions that you have done a tremendous work in with ISRO ASTROSAT mission. So please tell us about that.
Okay, so there's two aspects to my research. One part is the science part, the astronomy part. And the other part is what you might call more of a technology part, where we build instruments to go into space. So the science part, what I'm interested in is interstellar dust, interstellar gas, and those type of phenomena. These are, when you look up in the sky, you see stars. But as I can see in the picture behind you, there's a lot of interstellar dust and gas out there also. And so that's what I study. And I study it in the ultraviolet, because the ultraviolet is, as you know, to the blue of blue light. It's shorter wavelength than blue light. And it's where a lot of the transitions that you get in interstellar processes. When you look at hydrogen or oxygen or any of these, a lot of the processes occur in the ultraviolet. Now, in order to look in the ultraviolet, you need to go out into space. So this connects with the other part of my research, which is into space missions. So we go into, we build in my lab at IAA, with my group, we build instruments that we try to send out into space.
Okay, sir. So one thing that you have said that you you find or you research the stellar dust in ultraviolet rays. So last time when I had Dr. Ananda Hota with me on the podcast, so he used to work in the radio astronomy part. So please tell us about more about the ultraviolet part, because if I'm not wrong, that the wavelength is not that big with the, like if I compare to the radio is very much very bigger wavelength, but here the frequency part is more dominating. If I am stating it correct, I don't think the dominating word is that much correct for the for stating this thing, but the wavelength is not that big. So how are we going to study the whole universe? Are we studying the whole universe, like the galaxies from the far away, like to millions of the light years, or are we studying the our solar system and the things in our neighborhoods, kind of thing? Are we studying that?
So I apologize if I'm going too far into the basics, but let me start. I'm sure many people will have questions about this. So the electromagnetic spectrum, if you think about it in wavelength, it goes all the way from gamma rays, which is in the far, very short wavelength, up to long wavelength radio waves. Frequency, it's the other way around. High frequency gamma rays, low frequency radio waves. Now, you know that the energy is hc over lambda, or h nu. So the shorter the wavelength, the higher the energy. The longer the wavelength, the lower the energy. And so when I study light, when I study the universe in the ultraviolet, I'm studying it at a reasonably high energy. What kind of, and you know, energy is the same as temperature. The faster things move, the hotter it is. The slower things are, the cooler it is. So I study things at temperatures of about 10,000 to 100,000 degrees, 10,000 degrees to 1 lakh degrees. Ananda Hota, he studies things at temperatures of maybe 20 degrees to 3 degrees to 20 degrees. Now, the other part of this is that as you look out, as you go further and further out into the universe, you're starting to look back in time. And so you start to worry about the redshift. So when I look at the ultraviolet, I'm looking at the low redshift universe. I'm looking at the universe within a few thousands of light years, maybe a few tens of thousands of light years around us. So I look, my own interest is largely in our own galaxy, but you can look out into nearby galaxies also.
Okay, okay. So basically, not the like in the radio astronomy, they are finding the new galaxies, but you are finding something. If I say you are finding something in our own galaxy, some details in our own galaxies, and we are trying to studying that. Is that correct, sir?
So let me say also that we're looking at different phases, even of our own galaxy, we're looking at different phases. So what I see in the ultraviolet are mostly atomic and molecular absorption and emission lines, but these are electronic transition lines. So if you think of the Bohr atom, the hydrogen atom, n equals 1, n equals 2, n equals 3, in the ultraviolet, what we see is those transitions between n equals 2 to n equals 1, n equals 3 to n equals 1, and so on. And similarly for other atoms. In the radio, what you're looking at are more the rotational and vibrational transitions. So you're looking at more molecular transitions, or the low energy, very low energy atomic transitions. I'm looking at the higher energy atomic transitions.
Okay, okay. So let me come to the next question. So please tell us about the AeroSat mission. That is AstroSat mission. Sorry for the mispronunciation. AstroSat mission. I was reading about it. It's something about the multi-wavelength project. Like we have sent a multi-level like a satellite which can explore the universe in multi wavelengths. So it will be studying radio and ultraviolet both at same time, or is there something else? Please tell us about your contribution in that, and about the working of that the project.
Okay, let me actually start a little earlier. So the ASTROSAT mission started in, I believe, the late 1980s or maybe early 1990s. And there was a discussion. ISRO said, we want to put up a mission to do astronomy. Of course, NASA has done this for years. So NASA has always believed that, that science is an important part of their mission. But ISRO was not set up that way. ISRO was set up the mandate to do space research or space science for the common man or common person. And so things like remote sensing, communications, that type of stuff. So they decided that astronomy was let's do some astronomy. And so they wanted to have an astronomy satellite. So they called the community and asked them for ideas. And the two ideas that were strongest was an ultraviolet mission and an X-ray mission. So ISRO said, okay, let's combine the two and let's have a multi-wavelength ultraviolet and X-ray mission. There's some synergy. If you look at something like the Crab pulsar, the Crab Nebula, you can see it in both X-ray and ultraviolet. So there's some synergy, but a lot of the science is also different. And so when I joined IAA in 1999, that was when the mission was first approved by ISRO, a little later, 2000. And so where I started was I worked along with my colleagues in the first design of the ultraviolet instrument, UVIT. And I was also responsible for getting the detectors and some of the early software design for the mission. The difficulty for me is that ASTROSAT took 13 years. And that's too long for me to spend on any one project like that. So somewhere in the middle, I started developing other interests and other people started coming into the project. And so now ASTROSAT, it had many people. When it was launched in, what was it, 2015, if I remember right? And it's been up, it's working well, doing lots of good science. So it's ASTROSAT. ASTROSAT is one way of doing science. It was, they brought together scientists from many different institutions, and they built a fairly large spacecraft, 400 crores. And as I said, it took 13 years. I think that now they're still trying to do some missions like that. There's the INSIST mission that IA has proposed. There's Aditya, which will go up next year or the year after. But these are again the big missions. But I think there's also scope now for smaller, more nimble missions where maybe you don't spend 13 years. Maybe you can do a mission in 2 years. Maybe instead of spending 400 crores, you can spend 40 lakhs or 1 crore max. So there's scope for more opportunities.
Okay, we will be talking about that also in the later part. But let me come again on the ultraviolet part. So, sir, you have been studying the universe under the ultraviolet light. So, what kind of things that you have found, or what kind of things that you have been searching, or you have been researching on under the telescope with ultraviolet light? My phrase might not be that correct scientifically, but I just want to ask that uh, ultraviolet rays, the ultraviolet region of the spectrum that you have been using for your research, what kind of things you have been searching while under your research?
So the ultraviolet is, as I think I said earlier, you were looking mostly at our galaxy and maybe some nearby galaxies. So what you're looking at are the hot young stars. So our sun is a G star. Our sun doesn't put out any ultraviolet light. And it's about 5 billion years old. Maybe it'll live another 5 billion years. what
Well,
we see in the ultraviolet, go ahead.
okay. So, sorry, I apologize for interruption, but there is one thing that you have said,
Go
that
ahead.
our sun does not emit any ultraviolet rays. That's what you have said. Uh,
So it's an
okay,
approximation.
so
The sun is a black
approximation.
body with a
Okay.
temperature of about 6,000 degrees.
Okay, because
And
I
so
would
what
like
the
to
sun's
ask
light,
that, because
uh-huh,
the ozone hole depletion and all the things that we heard, that ozone layer is there, so it is about
yeah,
to
sure.
it is there to just to like protect us from ultraviolet rays from sun. So we have grown up while by studying that only. So please tell us about that how, as a astrophysicist, you are saying that sun does not emit ultraviolet ray. I know there might be a catch, like that much amount much must be needed for a star to emit that much. So please tell us about that, how this statement joins with our knowledge, like our layman knowledge.
Sure, sure. So the first thing you have to understand is that everything in astronomy is huge. And so the sun is a G star, and it's very near to us. So even a very little amount of radiation from the sun, in astronomical terms, is actually quite a lot when you think about us. The other thing is that the ultraviolet is quite a big range. It goes all the way from 100 nanometers to maybe 300 nanometers. And so what the sun's radiation dies out by about 250 nanometers. So you get this UVA, UVB, and I don't really know all those terms, but the problem with the ozone layer, as you said, is that because we were destroying the ozone layer with chlorofluorocarbons, CFCs, enough ultraviolet light from the sun was getting through that it would increase the rate of skin cancer. That amount of light is still much less than the amount of visible light. So the sun is much brighter in the visible than in the ultraviolet. But because the sun is so close, even a little bit of ultraviolet is enough to give us cancer. The other complication is that the sun is composed largely of hydrogen. And so you have this, the n=2 to n=1 transition of hydrogen, Lyman alpha. The sun is very bright in Lyman alpha. So when I say the sun is, or when a G-type star like the sun is not very bright in the ultraviolet or has no ultraviolet, it's compared to its optical emission. If the sun were at the distance of any other star, we wouldn't even see its ultraviolet light. It's only because it's so close that we have to worry about it.
Oh.
So when we look in the ultraviolet, what we see are the blue stars, O and B stars. And the O and B stars are big. They're much bigger than the sun, and they're very hot. They're temperatures of maybe 20,000, 15,000, 20,000, even 30,000, even 50,000 degrees.
And we are talking
so
about the
these
surface
emit a lot of
temperature.
ultraviolet. The surface temperature, that's right. The core temperature, of course, is 10 to the 7, 10 to the 8, 10 million, 100 million degrees. Yeah. Because otherwise you don't get fusion.
Our sun is around
So
6,000 Kelvin, huh?
At the surface.
At the surface.
At the surface, the sun is about 6,000 Kelvin. Which is much less. Yeah, okay, 6,000 Kelvin. And so when we look out into space, what we see is basically the light of these stars, which shine through a galaxy. They ionize gas, they heat up dust, and they reflect from dust. So again, in the picture behind you, over to your right, to my left, there's that whole scattering. Yes, that's right. That's a reflection nebula, which is from light from those stars being scattered by that interstellar dust. And so that's what I study. I study mostly the light of these hot stars, either in emission lines from interstellar or absorption lines from interstellar gas, or as scattering phenomena from the interstellar dust.
And what does it tell you about the universe? Like, what does it tell you?
It tells you the composition. It tells you if you the ultraviolet is where you do physics. So it tells you the composition. It tells you the temperature. It tells you the whether it's being shocked. Are there shocks going through? So it tells you the dynamics, the energetics, the different ratios, how much hydrogen is there, how much oxygen is there. So all of this comes from the ultraviolet emission.
Okay.
Molecular hydrogen.
Okay. Okay. That's much very much interesting, and I think all the people who are watching this podcast must be having a lot of doubts about this podcast. Like whatever we are studying, you might be having your doubts, so you can just put your
But I'll
doubts.
tell you one thing further.
Okay, sir.
I'll
Okay.
tell you one thing further, which is that we always do try to relate it to the broader picture. What is this importance in terms of the universe, in terms of our daily lives, whatever you want. But at some level, we study it because it's there. So why are we interested in interstellar dust? Just because we want to understand about the interstellar dust. That's an end in itself. Yes, I can then place it in its larger context in energetics of our galaxy, how it reprocesses the stellar light, and so on. But it's important just because it's there.
You just answered the most asked question that I always get, or I always get from someone who's not from science background or who's not interested in astronomy, that why are we spending that much of money? Why are we doing this? You
I can
just
tell you the broader answer.
please, sir, please,
because
sir,
we're humans.
Because I have been searching for this by myself, because I'm a science enthusiast. I am a astronomy enthusiast. I love studying astronomy. I love studying. I love talking to people who are related to astronomy, like you. But I don't have answer to I don't have any answer if my mother asks me that why are we spending that much of money on space missions, and why are we spending that much of money on this kind of research. So if my own mother asks, I don't have any answer. If my own sisters ask me this question, I don't have any answer. Please, I would love to hear that, and I know that audience would also love to hear that. Please, sir, please.
So let me answer it on two different levels. Okay, one is the purely economic argument. So let me start with the purely economic argument, which is that it's not much money. In India, we spend 0.7% of our GDP on all of basic science. And by basic science, that includes ISRO, it includes the CSIR labs. So that's not what I call basic science. What I call basic science is basic blue sky research. So we spend 0.6%, 0.7% perhaps. It used to be 1%. Now it's about 0.7%. You look at the US, that's about 2.5%, 3%. China is 2.5%, 3%. Israel is probably 5%. So these advanced economies spend much more of their much larger GDP on basic research. So when you ask, why does the US get the Nobel Prizes? They spend a lot more money. Now you look at where innovation comes from. Why did Silicon Valley grow up in California? It's because of Stanford and Berkeley. I'm from Johns Hopkins. That whole area in Maryland is a biomedical hub. Why did it come? It came because of Johns Hopkins. The APL Center of Hopkins does a lot of defense research, and there's a lot of high-tech industry around there. Again, Boston, MIT, that MIT corridor, again, same thing. Even in India, you look at Bangalore. Why is Bangalore the science and technological city of India? I mean, it's where all the startups are. It's where all the science is done. It's because of ISC and because of all the colleges in Bangalore. So this is the purely economic impact. if you want to look at the paradigm shifts, not just build a car that uses 10% less fuel, but the car the hover car, the car that flies. That's what you need science and innovation for. And that's what we do. Our job as academics, our job is not to necessarily build that car. Our job is to teach people like you, like other students, how to think, how to do new things. So that's a purely economic aspect. People often argue for science on the basis that today's advances are yesterday's basic research. Something like lasers. Lasers, you have lasers everywhere. The computer you use uses lasers. If you need surgery, you get lasers. When you go to a shopping to a department store, they use lasers to read the prices. So lasers are used everywhere, but lasers came from basic research. X-rays. How can you live without X-rays? Basic research. So that's the practical argument. But I have a more philosophical point, which is that we're humans. We're all people. Some people like dance. Some people like art. Some people like dance and art. People go and are happy to spend 500 rupees to go watch Shah Rukh Khan, do whatever he does, or whoever it is. And so this is what we do. What is the purpose of that other than to make Shah Rukh Khan rich? What other purpose does my going to see his movie have? And this is what we do. We have a curiosity. We want to learn. We want to do things. We have to find out about the universe. And this is what makes us human. So this is why we have to do basic academia, not just science, but also historical research. Also, what color underwear did William Shakespeare wear? These are things that are just of interest. Why are they of interest? Just because. There was this really neat story once. They were learning how cockroaches navigate. And they had these little funnels on their antenna to show that who would think of putting funnels on cockroaches' antenna? But this is what we do. And if you ever look at the Ig Nobel Prizes, that's what they say. First, they make you laugh, then they make you think. And that's why we do science or history or geography or anything. It's because we're humans and because we want to expand our world.
Oh. So after so long, I got my answer, and I will try to tell you guys also that what I have got, because in the last podcast, Verma sir have taught us like what you have got, what you have understood might not be what I have understood from the same teacher. So this might be so I'll be sharing what I have understood from this talk. So I'll be sharing my views also in another video, and that video would be certified by sir also. And so I'll be taking some points from sir. So sir, I know this part of your research is going again to the part 2 that we do, what we do, the common talks about the about the institutions and all. But there is something interesting that you are doing, which fascinates a lot of kids, kids like me, like my like other people who who think that astronomy, if we do astronomy, we sometimes get to see somebody like us in the outside from the earth, so that we call them as aliens. So you're studying about the aliens, and not and you're not studying about the aliens like the micro life and all. Your research is about like the intelligent form of life outside the Earth. So please tell us about your research, and there is a project. SETI, SETI, which you are a part of. So please tell us about that project also, and that's very fascinating.
Okay, let me actually correct you. I don't actually do anything with SETI. It's true, I've had a couple of papers in it, but that was just fun stuff that we were doing. And even though it is a fascinating subject, because what could be more fascinating than finding life somewhere else, and especially intelligent life? But the thing is that it's a large field, and there's already so many people working in it. And what I found, I'm a pretty smart person, and so I learned. I tried to think of things that other people hadn't thought of. But the fact is that there's so many smart people out there, and they've been working on SETI such a long time, so that anything I thought of, they'd already worked on. So this is the trouble with science now. Now you become an expert in some area. So I'm an expert in interstellar dust, in the ultraviolet radiation. I'm an expert. But now if I want to apply my expertise if I want to shift my area of expertise to something like SETI, it's just such a long a lot of learning. So I'm interested in SETI more as a matter of interest. I give talks on SETI, but that was just because I wanted to learn about it. I wanted to find out what had been done. So easiest way to do that is to put together a talk. So I put together a talk on SETI. The stuff I've done on SETI is very little. It's some part of, it's a collaboration that we had to do machine learning, apply machine learning to astronomy. And that it's gotten somewhere. It's a lot of new techniques, but not pure SETI per se. So in India, there's not very little SETI work. We're trying to build, or ISRO has, I believe they've approved a spacecraft or an instrument to look for exoplanets. And there's my colleague Sujan Sengupta searches for exoplanets, but there's not much work being done in the country.
Oh, okay, okay.
So please do ask Professor Sujan Sengupta for exoplanets. He'll be happy to.
I'll be writing the next mail to him.
You please.
That's my work, sir. After the interview, I'll be asking you who are the next number of people I can invite on my podcast, and
Sure.
and can get the knowledge, the maximum knowledge that I can provide to my audience. That's the thing.
Yes, of course.
That's what I do. And so also, sir, you said that you have not done that much with SETI, but you might have collaborated, or you might have met some people who have been working in SETI. So please tell us something about that. Are we getting how are we proceeding to find any extraterrestrial life? And we are like in SETI, it stands for search of extraterrestrial intelligence. So what kind of intelligence we are searching for? Like the intelligence that animals have, or the intelligence that we have, like the humans have, like the intelligence that can build a technology or something like that. So what kind of intelligence are we talking in that particular sense?
So you're actually asking a broad philosophical question, and it can be difficult when we. So let me give you a little history. When I was a graduate student, there was no other planets known, or no other solar systems known, only our own solar system. The first extrasolar planet was discovered, I think, in 1987, around a pulsar. That was just after I graduated. And then then they started finding it by this radial velocity method. I think that was the early 1990s. the Nobel Prize of what was it, 2 years ago, 3 years ago. So, these weren't. So when I was a graduate student, there were no planets. So most of the search for extraterrestrial intelligence, the SETI, came like the movie Contact, came by radio telescopes. So they looked for radio telescopes. You may know of the what's it called, the SETI, the screensaver that you download, and SETI at home. So that was the kind of work on SETI that was done. You look in radio waves, and you look for signals with patterns in radio waves. Now, what happens is that after extrasolar planets started being discovered, now people said, okay, so now people are still using these radio waves to look for signals from space. They're looking through increased phase ranges. They're looking through larger and larger amounts of data. But now what people are looking is what another thread is that they're looking for planets that look like the Earth. You said, how do we know what intelligence they have? What kind of intelligence we're looking for? So now the problem is that we're trying to do science. We're not writing science fiction. And so when we do science, we just don't know enough to say, okay, maybe there are people on superconducting planets, very cold planets where they're silicon intelligence. We don't know enough to say that we can look for that. So what we do is that we look for life that's more or less like what we would recognize. Of course, that limits us, but it means that we're not opening it up to an infinite amount of number of possibilities. We're looking at a smaller range, and we're trying to do a deeper job on a smaller range of possibilities. So that's why we look for Earth-like planets.
Okay. So, sir, there is something which I have read somewhere, the wow signal.
Mm-hmm.
So, in 1977, we have captured a signal from the space that is popular as wow signal.
That's right.
And so please tell us something about that, sir. So many people like, there is some conspiracies are always there when we talk about these kind of things, that the signal was from highly highly intelligent life form, those like somewhere from the aliens type species, like the things that we call aliens in our movies. It was from there. So what kind of things that we know about the wow signal, and what discussion and what are the debates that are going on about that signal? So what we are doing with that knowledge?
A lot of the difficulty in searching for extraterrestrial signals is that science depends on reproducibility. So you do something, you do it again, and you get the same answer. When you're looking for signals from extraterrestrials, if that extraterrestrial person or alien only sent the signal once, then what do? You only get it once. And so with the wow signal, what happened was he had two dishes, and he had two dishes. And I'll just wait for this ambulance to go by.
There is another signal when we are talking about the wow signal.
maybe you could get the Doppler shift of that. So he had two dishes, and he measured a signal from, I think it was somewhere in Orion, in both dishes, and it was consistent with the rotation of the Earth. The Earth rotates, and so first you see it in one dish, and then you see it in the other dish. So it's consistent with that. And so he told everyone about it, but then people looked with other telescopes. They looked with optical telescopes and other radio telescopes, and no one found anything. So that's where we have to leave it. It was a signal that was discovered once, and it's very interesting. Jerry Amon himself thinks that it was probably an intelligent signal, but how do we ever prove it? And so that's where it is. It's an interesting signal. Maybe we'll discover another signal like that. But until we do, what can we say? We can just say, oh, it is an interesting signal. Maybe it's from life, but how do we know? And we can't do much more. You can't come to vast conclusions from half-vast data.
Yes, sir. Yes, sir. Yes, sir. So here the part one of the interview is over, kind of over. So we have talked about the SETI project, we have talked about the ASTROSAT project, and we have talked about the research of Dr. Jayant Murty, and we have talked a lot about why do we study astronomy and what are the impacts of studying astronomy. So now if you are watching this part also in the part two, so I welcome you all in the part two of the podcast, and here we will be discussing something about the science of this country and the astronomy of this country, and what are we doing, and what kind of institutions we have and we should have. We have and we should have, and we will be discussing this with sir. So, sir, my first question to you is, a lot of people ask that why are we studying astronomy, and we have talked about it, that why are we doing this, why are we
Mhm.
studying this, but there is something that a science student will always ask, that why are we not studying that much of astronomy in India? Because a layman will ask, why are we studying it?
Yep.
But as always, a science student will ask, why are we not studying that much of astronomy in India? Please tell us something about that.
So in India, we have a rather unfortunate educational system in which much of the purpose of an educational system is not to get an education, but rather to get a job. So why do you go to any college? You go to a college because you have the placements. They'll place you in some company. And the research part of it, this is quite different from the American system. The American system, you have colleges, liberal arts colleges, where you go to get an education. And as part of that education, the faculty do both research and they do teaching. And this we separated in India, perhaps partly because of the British. The British wanted to have trained people for the civil service, for the ICS and so on. And so we separated research and teaching. And a lot of what you ask, why don't we learn astronomy? Why don't we learn this? A lot of that is just because people have decided that you have a standard curriculum. And in that standard curriculum, there is no place for student interest. The student has to learn the curriculum. Not learn, but learn the curriculum. And this, I think, answers much of what you ask for, much of what you say. And our problem, I'm in an elite institution like the Indian Institute of Astrophysics, Raman Institute, IUCAA, TIFR. We cater to such a small number of people. We take maybe 100 students a year, and we take students only after they get their MSc, only for their PhD. And so we just don't have the reach that we should have. Where you get the reach is in the universities. And in the universities, because of the standard curriculum, there's just not much space for actual learning. The space is not because of the faculty. The faculty are often good. The faculty are often dedicated, not everyone, of course, but many of them are dedicated. But it's just that they're so busy teaching the curriculum that they don't have time to teach interest. mean, you're closer to that system than I am. I actually went to an American liberal arts college, so I have a completely different philosophy.
I've been talking about the system lately, and I've been talking to many people about this, about the system. And last time when I was talking about the system was with Dr. H.C. Verma, and we were talking about the new education policy and how the government is going to implement it, because we don't have that
See,
much of
I'm cynical about this.
because
I'm cynical about this because before the new education policy, this is now the new education policy. This is like the fourth time we've had a new education policy. And you have education policies brought out by a bunch of people who sit there, who've never taught a class, who've never been in a university system. They don't talk to students. They don't talk to the people who actually teach. What are you going to come out with?
We can't tell the truth about the politics. We can't do that.
I always speak my mind.
Sure, sir. That's what we need. Nah? That's what we need. The people with the caliber should speak. That's what this country always needed.
But no one listens.
But this is something that I always talk about, that education system in India. Like at when I was going for inters, like when I did my class 10th, and then I moved to the class 11th. So I took science, and I from class 9th onwards I started searching for the schools which have astronomy as subject, and I didn't knew anything about that. So I was not able to find any school with astronomy as subject in Delhi. So something I was trying to search, and something I was trying to get, but what I got was a school where I studied science, and whenever I asked questions like why is it happening, nobody was there to answer. Everybody was there that it is there and it will give you marks. Just get that knowledge and
course, yes.
just read it and move forward. Don't ask that much of questions.
Sure.
Always that was there. So you have been teaching in IAA, and many of the students might have asked this question, and many people ask me this question. And or anybody who is making video on astronomy, there is always one comment over there that, sir, I am a student, I am a science student, or I am a graduate student, undergraduate, or I am a student of class 10th or 9th, and I want to become an astronomer. So in India, how to become an astronomer, and is being an astronomer worth something, like if I say, like, how to become an astronomer is something that people ask, but I would like to ask that being an astronomer in India, does it worth it? Because do you get much opportunities to do the research in the topics that you are interested? Is it there in India, or there is something other? There are some other things that we need to know.
Where there are opportunities, and there are going to be more opportunities, because everyone recognizes, including this new education policy of yours, they recognize that you have to have research in tertiary education. You cannot do science, you cannot teach without research. And so these opportunities are going to be there. Now, of course, this is India, and I've been expecting this to happen for the last 2 decades. So things go slower than you might like. But nevertheless, there are opportunities. Now, the kind of research that is done, we have maybe, if you look at actual research quality astronomers, there might be a few hundred, maybe anywhere from 200 to 5, I don't know the number, but let's say 200, 300 astronomers, which is small in the global context. And astronomy in India, it's heavily weighted to optical astronomy or theoretical astronomy or X-rays. There's areas in which radio astronomy is huge in India because of GMRT. And so there are areas of astronomy which are very well represented in the country, but that doesn't mean that you can't. Science is global. Science is international, and so you can do whatever you want. In many ways, you have the freedom to do whatever you want because your salary is guaranteed. You're okay, that can be bad in that you're paid whether you work or not work, but at the same time, it gives you the freedom to do what you want. And so I don't think that there's any real bar to doing astronomy in India. What I would, there are good opportunities for PhD students. The ISRS, University of Delhi, all of our research institutions, we all do world-class research. Typically what people do is that after they get the PhD from one of our institutes, and they go outside for 1 or 2 postdoctoral fellowships, and then often they come back to the country and they get a faculty position in one of the reasonable places, and they do good research after that. So I don't think there's anything really to be worried about. On the other hand, it is a long process. And so if you might, let's say your family needs you to work by the time you're 25, that's not going to happen. Typically, you don't get a permanent position till your mid-30s. Okay, so this is the kind of calculations that any student will have to go through.
And what is the path in India that a student can follow to become an astronomer or an astrophysicist?
Yeah, so the first thing to do is to get a good physics degree. What we look at is the physics knowledge, basic physics, because as astronomy, astrophysics, it's a branch of physics. So you have to have that physics knowledge. And that implies some amount of mathematical knowledge. So that's the basic. You can go to a good physics degree, physics university, but you have to do more than just what's done in the college. You have to read on your own. You have to learn on your own, do problems on your own. So that's what you do. There's a number of colleges where they do teach astronomy at the bachelor's level. So places like Christ University has a pretty good astronomy program. I think MG University in Kerala, probably Delhi University. So there are places where they do teach astronomy. ISRS are excellent. Even though they're young, they're doing an excellent job. ISC now has this excellent BSc program. IITs have good programs, and there are universities where they do teach well. So you have to look, you have to do your own research, and find out.
Okay, sir. Okay, and a lot of people ask this question, that how I can become an astronomer and how I'm going to be like an astronomer, and what life do we have after becoming an astronomer. So a lot of people might have got the answer of how they can become an astronomer. First, you need to have a physics degree, and not just degree, you must be having the knowledge also. So just not the
and the learning, reading. Yeah,
not
that's right.
not just the degree will give you a position of astronomer, but a good knowledge and a good hand in mathematics also would help you in becoming an astronomer. So sir, lot of TV series, a lot of TV shows have been made on astronomy and astrophysics, and uh, like Cosmos, the Space Time Odyssey, the recent which I have saw, Space Time Odyssey. When I was in class 11th, or I think I have given the class 10th exam, and it was published on Nat Geo. So I saw that program, and a lot of programs were there when on the astronomy and astrophysics. So it has become a kind of between between people. It has become kind of something like a science fiction, but not science fiction. It is science, but not science, but kind of science fiction. It has become like that. So what actually the do we study in physics, astrophysics lab? Please tell us about that. That what actually an astrophysicist in his lab is doing. So is it that beautiful thing, like the beautiful are we just dealing with the beautiful pictures like the I have behind me, and studying that thing, or are we doing something much deeper than that?
So in a scientist's lab, in his or her lab, in their lab, in their office, the difference is that a lot of what you see, it's a glitzy stuff. It's fancy things. It's things that are made to sound exciting, the nice pictures and so on. But when the researcher works on their data, on their science, it's a profession. We're doing it as a full-time job. And so when you're a professional scientist, you lose a lot of that excitement of the amateur. It is true that astronomy is the field that probably excites more people than any other. People want to go into astronomy, they want to learn about astronomy. But when you're actually working in the field, now you're sitting at your computer. A lot of what we do, of course, is computer work. So you're sitting in your computer, you're writing programs, you're maybe you're preparing your classes, you're writing papers. So a lot of it is you've heard that term, science genius is 99% perspiration and 1% inspiration. Edison. So this is it. This when you're actually when you're an amateur, now you can just focus on the excitement, because you're not really trying to understand how things work, or rather you understand how things work at a more superficial level. But when you're trying to do the new things, the things that no one has ever done before, now that's just so many wrong angles that you go in. You go down this way, no, that way is wasted. You waste months and months doing wrong things. You spend months and months writing programs just to find one little thing. And so the excitement there is when you suddenly decide, hey, now I understand this. But that's a small part of the whole thing. So that's the difference between a professional astronomer and an amateur astronomer. We have to do it, and we have to sit and do it, whether it's interesting or not, on the hope that eventually we get an interesting answer.
So what are your thoughts on the shows like Cosmos, like how the universe work, or shows like that, those shows that telecast on Discovery Channel or Nat Geo, which are telling about the astronomy and astrophysics, but in a very fancy way, or in a very pleasing way. So what are your thoughts on that? And if a students watch that program and gets motivated to get a degree in astronomy, in a degree in physics, and then get into astronomy, so how do you see that?
I think that those shows have a very important role. One, the most important role is that they bring astronomy or science in a broader sense to everyone. So in just the same way, I'm not a professional historian, but I like reading history. I like understanding how people in the past thought, what they did. So in the same way, these shows bring science so that and they present it in a way that are interesting. After all, who wants to watch a whole hour full of people just writing equations on the board, or people sitting and typing on a computer? You want to see the exciting stuff, the fancy movies, the movies of two black holes colliding. That's what you want to see. And I think they do a wonderful job in that. So I think they're very necessary. And if they can inspire people to do astronomy later on, I think that that's great. The only caveat I have is that people shouldn't think that just because they read a brief history of time, that now they can they can do what Stephen Hawking did. There's a big difference between knowing enough to write a brief history of time without equations and actually getting that knowledge. So that's my only caveat, that one shouldn't and unfortunately this is true, and it's true in everything. It's true in history,
and that was my next question, sir.
And
that was my next question, sir, to you, that there are not just the shows, but there are books out there, that the brief history of time, or the briefer history of time, or the grand design, and the books which Professor Stephen Hawking have written, or maybe the books from Neil deGrasse Tyson or Brian Greene, somebody from the famous people that we have in astronomy, yes, astrophysics, yes, because they do this television programs. So people often think that after reading those books, after reading those things, so we can become an astronomer, and we can get a degree or get something. Even I was like that, because I have read some books, and I thought that yes, I can do astronomy, and I'll be doing astronomy, and that fascinated me. But when the actual research came in front of us, and we have to deal with the equations, and especially with in this modern era, we have to deal with the computation part. So a lot of people lose their motivation. So have you ever had any case like this, like some scientist enthusiast came to you, and then worked with you, and then lost all the motivation and all the interest in the particular field?
Yes, I have had the people like that, and it is always difficult, because you go in with some ideas, with some hopes, and then for whatever reason, you find that maybe it's not what you're really interested in. So yes, it happens. And in the US, my PhD class, when I started, we had 25 students. Only 8 people actually got their PhD. Out of 25, only 8 people got their PhD. Other people decided to drop out. They got a master's. They did something else, and I think that's perfectly valid. It's anywhere from 5 years to 7 years of 15-hour days, and it's not for everyone. I'll tell you, in fact, I started my first year, I was a biology major. And then I decided I didn't like biology. I mean, I like biology, but not enough to do research in it. So I switched from biology to physics.
Okay, so the next part, we will be talking about you, sir. In this part, we will be talking about you, and how you became a scientist. So please tell us about something about your childhood. How was your childhood, and how you got your initial education.
So I've always been interested in I've always read a lot. I read everything: fiction, nonfiction, science, history, biology. I mean, I read anything. And so I've done this from a very young age. From the time I was, I don't know, 4 years, 3 years, 4 years. I've been reading, and I've been reading science books also since then. So it was always clear. I was always very clear that I wanted to become a scientist. From that age, you can imagine, from the age of 4 or 5, I wanted to become a scientist. And my mother, in fact, was a PhD. So that she was the first woman engineer in Canada. I mean, in Nova Scotia, where she was doing her PhD. And so when I was 8 years old, Neil Armstrong landed on the moon. And so that you said yourself, space is exciting. And so this excited me about space. And then over the next decade, schoolwork, but I always read. I always read many things.
So you were born and brought up in Canada?
Was Isaac Asimov. No, I moved around. I spent a few years in Canada, and then I spent a few years in Zambia. So I did my high school in Zambia, and it was an international school.
Okay, okay.
So always I've read science.
Nice.
And then when I joined Johns Hopkins, then as I said, I started in biology, but then I switched to physics after 1 year. I was always taking the physics courses anyway, because in a American university, you have that freedom. You have the freedom to take the courses you want.
Nice. That's a beautiful thing, that you can switch the courses. In India, you can get beaten up on that you don't.
Again, now they're changing, and part of the even before this new education policy, this common, whatever it's called, the Common Core or whatever, the UGC program, a lot of them that you can switch around. So in places like ISRS, or ISC, where you don't go into one field at the beginning, but you take a general subject and then you specialize later on. Otherwise, 17 or 18 is very young to decide what you want to do for your life.
Even 15 also. Like if in 15 we get divided into science, commerce, and humanities. So
that's right.
That's also too young, and even we don't have that freedom to get that decision with us. It depends on what the family needs and what the mark says. So if we have CGPA greater than 8, you cannot go for commerce or humanities. If you even want it, you cannot go for that.
Absolutely, yeah.
So
that's even worse for girls. So many more social implications for women. That very difficult.
Very much
patriarchal society.
that would be another discussion. I won't say a debate. That would be another discussion.
Of course,
totally another discussion about how women in science are doing, and how what are the difficulties that they are facing because they are women. So that's also a true truth, and because we are men, so we don't actually know about their struggles and about their everyday problems that they are going through when they are in science. But we'll be talking about that also. So sir, please tell us about something like do you had any stories from your teachers, like you had some different kind of attachment with a particular teacher?
No, not really. I always
teacher, or maybe your student.
Again, not so much, because I always kept it more professional. So my interactions with my teachers and with my students, I've always tried to keep it more professional, less personal, because what's important to me is the work that's done, what we learn, not so much the social interactions. So no, I don't. I can't say that I really have that much to say about that.
Okay, okay. So, uh, so what do you think about today's era, where we have Instagram, Facebook, and other social media platforms? So maybe and Twitter also. So a lot of students might have asked you about this, that are you on Facebook, or are you on Instagram, or are you on this platform or not? So there was a time when there was a distance, not, I won't say that distance, but there was something between the teacher and student, with that we don't cross that limit. So but today we are hanging out with teachers, and something like that, and we are tagging them on the Facebook and Instagram, and those things are happening. And I'm not saying that is wrong or right, or I'm not putting it into under an umbrella of wrong or right. I'm just saying that the things have been changed. And what is the difference that you have saw from your time to this time? And when today you think about your time, and what are the visuals you get, and what kind of things you like, what are the things that you think about, that yes, we used to do this, but the student today are doing this? So what are those things? Please tell us about that.
Here is the main problem with all of these. They're distractions, and I'm not saying good or bad, but they're distractions. And so for me personally, I don't use Instagram, and I use Twitter, but only to read. Excuse me, I pick up news stories from Twitter. Facebook, I post more on. But these are all distractions. And so some of them, they're very valuable. You know, if you're a science popularizer, then of course you have to use Twitter and Instagram and TikTok. I mean, TikTok is banned, but whatever. You have to use these, and you reach many more people this way. For me, because I have to balance doing research with my outreach, with my popularization, if I don't do research, then what am I going to popularize? Right? There's nothing wrong with popularization. I think that's a very valuable thing. I think that people should popularize, but you have to balance your time. And I prefer to balance my time more towards the research part and less towards the popularization. So I enjoy these talks, for instance, that I've had with you. I enjoy giving talks, and those use up some fraction of my time. I engage on Facebook to some extent. That again uses time. If now I were to add Twitter or Instagram, that would again take up more and more time. So that's why I limit my own social interactions or my own social messaging.
So you have said that you played basketball in grad school, and so what were your favorite sports to be played? And uh, apart from basketball, and what kind of basketball you have played, like just for fun, or at some level, at college level, or at inter college level?
No, unfortunately, I was never a good enough athlete. I would have loved to play professional basketball, but I was never a good enough athlete. So we had department teams. We would have regular leagues where the same 15, 20 people, we would go out and play 3 times a week. So that was, I was also on an ultimate frisbee team. So this is what we did. We maybe throughout my college career, I would spend almost I would say 15 hours a week in sports.
So, what was your favorite sport to watch? Do you love watching sports? Do you watch sport or something?
I do watch a lot of sports. So these days I watch professional basketball. I was never interested in cricket. So mostly basketball. And whenever the World Cup, I'm not much of a football fan, mostly because I don't know the players. World Cup time, I watch football. And of course, Olympics. I don't miss the Olympics. That's about it.
Nice, nice. A lot of like, okay, forget it. People are talking about the cricket these days, and a lot of debate is going on on the cricket and
Yeah,
sports.
when IPL first started, I was a big Royal Challengers fan. But then they never went anywhere, and so then I just lost interest. And so now I don't even
I,
know. I
I
didn't
I
even know
till
that
date
India lost to
I
Pakistan.
I till date follow the Royal Challengers Bangalore, but recently I heard that Virat Kohli is leaving the captaincy, so I'm just out of
I
all.
heard that.
I'm going
Yeah.
to Himalaya.
Right,
I don't want anything else now.
right, right.
So because that guy had a caliber to get a trophy, but he never got a trophy. So
Right.
that just makes me something like, because I am a fan of that guy. So
Yeah. Yes, of course.
do you watch
Great
movie?
player.
Yes. Oh, he is. So do you watch movies? Uh,
I watch a fair number of movies
so
these days, especially with Netflix. Maybe around 10:30, just before sleeping, I watch a movie for half an hour, and then
what kind of genre do you
so
love?
it takes a.
There is a particular genre, or you
Of
watch
course,
something?
no, I watch many different kinds of movies. I like action movies.
What kind of
Well,
action movies, like the martial art type
of
movies,
course,
or
no, not much martial arts. More the James Bond type.
oh, okay, okay,
James
okay,
Bond, Denzel, like Denzel.
okay, okay, okay. So do you watch Marvel movies or some superhero
I
movies like
do. I do watch the Marvel movies. So I'm looking forward to watching this. What's his name? The Chinese
Shang-Chi?
superhero, the one
I was
Shang-Chi.
waiting for that to be released on the Disney Plus because I wasn't able to
It's out
get into
now.
the
It's
theaters.
out
Yes,
now.
it's out now.
No, I couldn't
Yes,
go to. Yeah.
yesterday it was released. So
Oh, yesterday is it? Yeah.
I was looking forward for it, and I'll be watching it with my friends. Maybe
Good.
probably
Good.
this week. Probably this week I'll be watching that.
Excellent.
So that was a beautiful talk that we had, and a lot of things that I have heard today was like I really got most of the answers of mine, which I always had, and I always had a doubt, and it was great to have you on the podcast. Thank you very much, sir, for being on the podcast. And if you would like to give any advice to the audience member, please, I would love to have that advice. And pardon my
No, what I
English.
would sure. The only advice I would give is that I think it's wonderful to learn about as much as you can. So and don't just do it by going to websites, but actually read books by respected people. Brian Greene, you mentioned Brian Greene, Hawking, of course. And if you're interested in going deeper into the field, then by all means do so, but do it at a proper level. Try to understand what's happening. And so I would encourage people just to learn, just to find out.
There are a lot of things that we haven't talked yet, but if you have any doubt, if you have any questions, please ask in the comment section. The comment section is open for you to have any kind of discussion. The comment section is open, and any doubts you can send us a mail or something, and we will get back to the sir again after some time, with the new set of questions and with the new set of doubts that you people will have, and we will again try to get sir on the Rozender talks. Thank you very much, sir, for joining with us, and namaste.
Thank you.